Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahid bin Muhammad Arifin. My metric number is CN180180, and I will present for my PSM1, which is the design and development of aquaponic piping system for urban farming. Okay, so basically aquaponics is a combination of two systems, which is fish farming system and plant cultivation system in a one system, in a one recirculation system, which is it grows simultaneously in a one system, which is aquaponic system. And the system used in aquaponic is closed loop system. And aquaponic does not require large space because they are combined into two systems in a one system that complex. Okay, so the system does not use pesticide and does not use fertilizer because the vegetable, the plant get their nutrient from fish waste, which is the fish will going through the biofilter, and that the wastewater from fish tank will go through biofilter, and then from the biofilter will flow to the hydroponic bed. So the plant consuming dissolved nutrient excreted directly by fish or generated by the microbial breakdown of fish excretion. Okay, so there's several kind of method on development of hydroponic cultivation system, which is media bed, nutrient film technique, and deep water culture. So in our system, we use the nutrient film technique. So the system in our project consists of several units, which is fish tank, biofiltration tank, pump, and PVC pipe. Okay, so for the problem statement, rapid urban development make an area lack space and limited land to produce organic source. As a result, the organic source need to be imported from rural area for local consumption. Yeah, in the development, so for the development of aquaponic system, it will help the community to produce their own food sources, which is vegetable and fish, because this aquaponic system can develop in a small space, which is in the home area or in the abandoned place, which is abandoned factory, because the system is no need the strong sunlight. And the next problem statement is the designer only drew a single design and no design comparison was made to develop the aquaponic system. Okay, so basically in a process of sketching the design, the designer had a tendencies to choose the single design because they failed to optimize the design and the production ratio between fish and plant and setting up the pilot plants. So the selection of a single design is able to affect the quality of operation, because if we only develop a single design, it will affect the quality or the quality operation or the cost operation, because if we develop a 3 or 4 support design, we can able to to make a comparison on selection the best quality of the system. Okay, so for our objective is to design and make a comparison in selection of aquaponic system to fabricate a nutrient film technique based aquaponic system for urban farming that can growing aquatic species and soilless plant in a single system. And the last objective is to test the aquaponic system in terms of water, energy, and nutrient. Okay, scope. Okay, for the scope, for the first step is we need to design. We need to develop a design and develop a 2 or 3 design, and then we need to make a comparison on the best design that we will choose. After that, prepare the unit to be used, such as fish tank, biofilter tank, hydroponic bed, PVC pipe, and pumps. Okay, after that, we should run test phase, which is, in other words, is try and error phase for 10 days to avoid from technical problem during actual operation. So the technical problem that able to be in our project is maybe a head loss, the leakage or the spillage of the water. Okay, so the fish will contain in a 1,000-liter intermediate bulk container, and then the project will employ our air pump to ensure a correct level of oxygen dissolved in the water for the fish. And then the mechanical filter or the biofiltration filter that we use is made from plastic cylindrical barrel, which is approximately 150 liter of drum tank. And after that, water pass from the fish tank to the biofilter by pump. The filter water is then drained to the hydroponic bed, and then the purified water produced from the crop residue is then drained back to the fish tank with different flow side direction, which is there is a circulation system in the system, which is start from the fish tank and it will end up in the fish tank. Okay, so this is the fish tank that we use as a fish unit, which is we use 1,000-liter intermediate bulk container because this tank work very well as a fish unit in the aquaponic system by previous researcher, and the tank should be covered to keep leaves or material out of the tank and prevent fish from leaping out, or it can prevent from the kids or predator jump into the tank. So if we had a cover on the top of the tank, it will good for us. Okay, so this is the literature review from past journal for fish unit. Okay, so the plant unit that we developed is nutrient film technique, which is the hydroponic bed, which is the plant unit bed is made from PVC pipe, and the diameter of the hydroponic bed is approximately 3 inches, and then the plant seeds that the place in a net cup that with a diameter of 4 cm, and then stick it into the hydroponic bag, which is that has been drilled for 5 cm. So we attach the net pot into the hole drill in the PVC pipe, and so the the number of plants that we can grow in my system is 35 units of plant. Okay, so there is the summary from past journal for plant unit. Okay, so next is biofiltration. So the biofiltration that we use for this project is a combination of seashell and gravel. The seashell and the gravel is placed into the 150 liter of plastic barrel, which is we fill the bottom layer with gravel and the top layer with seashell, because this gravel can act as a mechanical particulate filter, trapping and preventing solid facial from fish from entering the seashell layer. And the seashell will act as a microcolonization base. Okay, so this is the summary from past journal for biofiltration. And then we going through the fish management. So for the fish management, the species of fish that we use in the system is tilapia, because tilapia are immune to stress and can tolerate a broad variety of water quality and environment factor. And because why I choose this tilapia, because this tilapia can grow at the temperature of 29 degrees Celsius, which is it is good because the water temperature for optimal temperature for growth is about 28 to 30 degrees Celsius range. Okay, so this is the summary for past journal for the fish management. Okay, so next we go to plant management. So the species of vegetable that we use is lettuce and pak choy, because the lettuce and pak choy can survive well in a high temperature. Lettuce basically can survive in range of 70 to 74 Fahrenheit, and this lettuce easy to farm because it matures fast, and it basically it maturing fully at less than 30 days. So while the pak choy also great in high temperature, which is pak choy can adapt to temperature range about 55 to 75 Fahrenheit. And pak choy also grow fast and is relatively climate tolerant. So this is the summary of past journal for plant management. Okay, next we will go to the water quality. Okay, so many factors may attribute to decrease in water quality. For example, in the aquaponics system, excessive fish waste and uneaten fish food may contribute to higher ammonia level in water, which can intoxicating the fish. Moreover, this system will cause water loss that it caused by the evaporation, evapotranspiration, spillage, leakage, and water exchange that will affect the water quality of the system. And to address this problem, a water recirculation technique was invented to keep the cycle of the water flow from fish tank to plant. And this system had to be discharged at a rate of 10 to 12 of the total ammonia volume in the tank daily. Okay, next is the process parameter, which is there are 4 stage in the process parameter, which is the first one is extraction stage, which is the flow from the fish tank, flow to the biofilter. It will call extraction stage, and then from the biofilter to the hydroponic tank is called filtration stage, because the water from the fish tank has been filtered from biofilter, and then it will go to utilization stage, which is it utilize the filtered water into the subsystem of the hydroponic bed. And then after that the flow from the hydroponic bed will drain back to the fish tank, and it will call a recirculation stage. So basically it is a closed loop system, which is the flow will continuously flow. Okay, so for the methodology, this is our flowchart, which is the first step. We need to find on research about Aquaponics system. We construct a technical drawing design, make a design selection, identify the dimension, the part or the material used, and then we calculate the cost of developing, and then we need the approval from the my supervisor, and after that the supervisor approved, I will go to the finalized design, and then fabricate the aquaponic piping system, and then testing the system. Okay, so the material chosen was 1000 liter intermediate bulk container, 0.75 horsepower centrifugal pump, 150 liters drum tank, PVC pipe, 90 degree elbow, and cross joint. Okay, so next is the morphology of design selection, which is we need to develop more than one design to select the best layout. So this is the first concept, which is use the same unit and equipment, but it difference on the hydroponic unit. Okay, so this is the concept. Okay, so this is the concept 2 that I have designed, and this is the layout system for the concept 2, which is that I use for the finalized design. And then this is the concept 3 design, which is it has a large scale of system, and it powered by 2 pump, which is the first pump is 0.75 horsepower centrifugal pump, and the second pump is 0.5 horsepower water pump. Okay, so this is the finalized design that I select for my project. Okay, so why I choose this design, because the use of because if we compare between the 3 concepts that I have been shown, this design provide an average use of equipment, and the cost to develop this project is average from the 3 design that I had developed. So moreover, this system is more efficient because the hydroponic bed unit, the flow from the biofiltration into the hydroponic bed, and it will guarantee the continuous flow, because the flow that enter the hydroponic bed will flow to the to the next subsystem by gravity. So that is my finalized design. Okay, so this is the cost of developing this project. Is approximately there are some unit that we use from previous project, which is my supervisor provide several unit, which is 1000 liter of intermediate bulk container, 150 liter of drum tank, and 0.75 horsepower of centrifugal pump. So that was the recycle item that I use, and the cost is 1230, and the purchase item that I need to buy is PVC pipe 2 inches, 3 inches, 90-degree elbow 2 inches, 45-degree elbow 2 inches, net hydroponics, and seashell and gravel. So the cost for me to purchase this project is 118 ringgit and 50 cents. So the total costing of this project is approximately 1348 ringgit and 50 cents. Okay, so before we continue, we need to test and fabricating the Aquaponics piping system. So the first step to fabricate the system is to measure the PVC pipe that have been used and refer to the design that we have been developed. After that, the pipe need to cutting into the size and length that have been required. After that, shape and framing the system, which is we shape and framing the hydroponic bed by using PVC pipe. After we shape and the framing, the last process is installation process, which is we install all the unit with the pipe or with the other equipment, and will produce an aquaponic piping system, a complete aquaponic piping system. So that is from me. This is the reference for this and thank you.